Hey, it's Granite. Oh. I don't know what you said. I don't know what you said. I have no idea. I haven't felt this good since 2019. Heck yeah! Woo! All right. I'm gonna switch this. Let's switch this. That's what I'm talking about. That's what I'm talking about, ladies and gentlemen. That's what I'm talking about. Feeling good, more than good. Yes. Yes, indeed. More wins. Inspired football. Yusuf inspired football. Felt cute, might start streaming. Wonderful. Look at that. Yeah, I like that. You finally. Ooh. Ooh, is that so? Ooh. Ooh. Well, I have to say I am very intrigued. Did it sounds like things went really well based on the choice that you made, so I'm really happy to hear that. Just need a better, yeah, you know what? You do need a good PC that's not going to run too hot streaming. And have a good connection, of course, but you can run it on technically on a potato, but yeah, it's like it's a little tough. I need to get some music here. So let's put an not this thing. Yes, yes, yes. Evil things. That is wonderful to hear, Granite. My thoughts on the Hersicle, which you're gonna catch on YouTube when it comes out, absolutely fantastic. Absolutely fantastic. You know, those guys were overdue for a really good game. They've had like one half that they're really good, one half that they're not, one half that they played, like beans, and then, I'm glad they finally put it together in one game where they just played, they played like they're up to their potential. My friend Granite. I'm my friend Granite. I got 4 minutes before class. I'm gonna tell you this. First of all, congratulations. Glad you made a choice that you are very happy and contented with, and that you have somebody who you can love and protect. Absolutely fantastic. I sincerely wish that you keep yourself on cloud 9. 100%. I'm telling you. Granted, I'm so proud of you. I'm so proud of the choices you made. I'm glad that things are chill. I'm glad that things have been wonderful for you, man. I'm only, you can talk to me, talk to somebody. I'll be more than happy to give you more support as time goes along. I just want you to be happy, and I'm glad that you are in a wonderful place right now. Um, fancy buying me, fancy buying me a computer. Not sure I have enough money for that anymore. But can't lie, made a little bit of money today, so can't lie. Just a smidge. No, granted, you should pat yourself on the back. You got yourself good stuff. You got yourself good vibes, man. Good vibes all around. Deserve just a nice relaxing. Guys, you deserve a nice weekend, man. Go out on a date, have a good time, just sit and chill. Just Just think of all the good stuff that can happen from here on out. Hell yeah. That's what I'm talking about, man. The only thing about the one I got at the moment is it has a webcam. Webcam is good. You know what? Yes, Malden and Tiptree are no pushover team. That's, you know, you're expecting a very tough a tough opponent in such a high league. They've been playing really well. And the men, they showed up. They showed up for real. They showed up for real. Look, I understand, Jamie, if you have a potato, okay? You got to upgrade the potato, okay? But you know, maybe you can't afford it right now, but you know, you could always do research and see how much it'll cost you to put pieces together. You may not be able to get the state of the art things, but you know, you can get things that are certainly cheaper. The only problem is that most parts are certainly more expensive since there's a semiconductor shortage, but still. If you could put together a good budget build, it is still possible. Good evening, Angie. Good evening to you. I hope you're doing absolutely fantastic. I'm not quite got. That's okay. You know, you can still build a budget build for 3 figures. It doesn't mean you need like the super fancy video card, okay? As long as the video card can still do the encoding, it doesn't have to be super fast. Okay. You don't need like the best chip on the market either. You thought I kept. You know what? Granted, I'm glad that you came to me for advice. And again, granted, I'm just gonna tell you, you're more than welcome to come back and ask me anytime. Okay. If you need some solid words or whatever, I'll be more than happy to offer it to you at any time. Okay. You're always more than welcome in the stream, 100%. Okay. Use of practicing subtraction. I'll be more than happy to help you if you need to. Yeah, see, that's pretty good. What's up, Fritz? How we doing, my dude? I hope we're doing well. Fritz, are we doing good today? How we doing, my friend? Yeah, absolutely, man. Look, you're more than welcome to come into my stream, Granite. Okay, trust me. Everybody and anybody is a welcome addition to this stream as long as you're positive and willing to bring forth the energy and, you know, wanting to learn. Sometimes in this stream we learn about math, and sometimes in this stream we learn more than just math. We learn about ourselves. And I don't think that's so bad. Good afternoon, Hisa. / evening, Hisa. Hopefully you're doing fantastic. Doing great. Everything good lately? But yeah, things have been very good for me, Fritz. It's been very, very good. I've been doing pretty well. Just been sitting and chilling, having a great time, just teaching. Looking at all these very happy faces. On a 4 o'clock on an afternoon. I mean, you can't go wrong. 4 o'clock in the afternoon, Central Time Zone, USA. How can you go wrong on a stream like this? 1000%. I'm doing good, Hisa. I'm doing good. Pistache, a good afternoon / evening to you. Look at the positive vibes. Look at the positive vibes. I'm on it to get one for a couple hundred from Curry's. Just one thing you should do, Jamie, just make sure you do your research, okay? Do your research. Read reviews about the parts you can get. Read the specifics, okay? Don't just go throw a couple hundred, you know. Make sure you do your research before you set out and buy. For example, on my box, although it cost me like 3,000, okay, it did take me like a good few months to research before I put the parts together. So again, please make sure you got everything in order before you put down any amount of money, whether it be even if it's a couple hundred. Always do your research just to be on the safe side, okay? So you're putting your investment in the right place that you can feel confident with. All right? Read the reviews, make sure it's not like bad products or something like that, so you're going to get taken. The answer is you can't. There you go. Hey. You can't go wrong. You can't go wrong. Yeah, just want to give a friendly reminder to you, Jamie. All right, so you're not caught unawares. All right. I don't want to be like, hey, should you know, sometimes people forget. That's right. Unless it's on that one anime girl from that one anime. Which anime girl are you referring to? There's a lot of them, let me tell you. How many of them do you want them to be your waifu? Hey! Waifu confirmed. Alright, ladies and gentlemen, we gotta do some intros here. I'm not going crazy on one, probably just gonna get a pre-built one. Wouldn't surprise me if I use it more. That's, you know, that's fine. If that's what you're gonna use, that's perfectly fine. If you're just using it for if you're using it for some applications and stuff, then yeah, desktop is a good idea. Desktop is a good long-term commitment as opposed to a short-term commitment. If you're just using it for internet, I always think a Chromebook is probably the best bet because it's super cheap. Being a laptop, and if that's all you're going to be using it for is just internet, then really you're not really using it for applications or anything of the sort, then Chromebook is the best in my opinion. Due to its cost accessibility. But if it's a more long-term, a desktop is much better than a laptop. So a laptop, while it's mobile, the issue with the laptop is that battery's going to die eventually, and you're going to have to get it replaced and redo everything all over again, and it still costs you probably just as much as getting a desktop. So yeah, so that's why I always suggest a desktop in that regard. All right, let's do some intros, ladies and gentlemen. We got some stuff we got to do today. I promise you. Okay, it will get done. All right, let's do it. Let's get started. Okay, let's get started today. Welcome back to Tuesday. Hopefully a nice weekend. All right, so for today, ladies and gentlemen, I want to give you a different type of reminder here really quick. Okay, remember that in, what did I say? Let me get that date one more time. That was going to be the 24th. Okay, oh no, the 23rd, sorry. The 23rd. Remember that the 23rd there, all right, remember, is the due date. Okay, due date for the homework and the test for chapters 1 to 3. Okay. So all the homework and tests, that is going to be the due date there, 9/23. It's already set in stone on my math lab, as you saw there last week. But again, just in next Thursday is when everything's due. Okay, so just as a friendly reminder, that is set and ready to go. All right, so we're good. Okay. Now, the next thing I want to talk about here is where we're going to be going next. And that is what we're going to be doing here next is we're going to be skipping Chapter 4. We're going to be coming back to Chapter 4 here. But Chapter 4 will be done at the end of the semester, at the end of this course here. But we will be doing the start here of probably the most fun section of probably most of these sections. And that is talking about probability in Chapter 5. Probability, super fun, super exciting, super chill. Has a lot of fun. Let's go to the big board, ladies and gentlemen. Let's go ahead and get started here with Chapter 5. Now, admittingly here, I will say this. We are actually at a pretty fast pace. Hey, no, it's fine, granted. You're more than welcome to stick around if you like. Alright? Thanks, bro. I appreciate it, though. So, what I want to talk about here today, let's talk about some probability. I want to talk about the probability that Granite's happy is 100%. All right, so I ain't gonna complain about that. All right, so let's go ahead and take a look here at some base definitions. All right, so let's go ahead and talk about those right now. Nah, I don't understand any of it anyway. Don't worry about it. It's no big deal. Oh, well, then. Take care, Granite. You have a great one. Okay. So, I do want to talk about this. Are we not doing Chapter 4? Again, Hisa, Chapter 4 will be skipped. We'll do it at the end of the semester here because it has more relevance for the last few chapters we do. as opposed to chapters 1 to 3. So you will see chapter 4, just it won't be done until the very end of the course. Okay. Okay. So let's take a good look here at question number 1. We're going to go over some base definitions here, at least to start off with. All right, so question 1 here. What is a sample space? All right, a sample space, the notation here for a sample space is the letter S, like capital S, okay? What's a sample space in terms of a definition? It's the collection of all possible outcomes in a probability experiment. Now, you could literally do any probability experiment. I mean, seriously, literally any. See, do I have that here? I forgot. I think oh, it was here a second ago. All right. Anyway, I guess I'll have to roll with that. All right. Okay. So, what is an example here? An example here would be like flipping a coin. So I'll put the coin up here. So of course, if this is a quarter, this quarter here, of course, has a heads and a tails. If I flip the coin, of course, I only have 2 possible outcomes of heads or tails, okay? That's it. If I have a 6-sided die, okay, a 6-sided die would have a sample space of 1, 2, 3, 4, 5, and 6, as those are the only 6 numbers that can appear on a 6-sided die. All right, so that would be the sample space in that regard. Okay, so depending on this, depending on what experiment you're proposing here, there's only going to be a certain number of outcomes that you're going to have once you go ahead and perform that experiment. Okay, so that is a sample space in a sense. Now let's talk about number 2 here that we can see here. All right, so number 2 is an event. Well, so what's an event here? An event is a collection of outcomes from a probability. Okay, now this could be one or more outcomes here. So I put a couple of examples down here. For example, if you roll on a 6-sided die, rolling a 4 on a 6-sided die. Okay, so you roll the die, it comes up as a 4, and then bada boom, bada bing, magic happens, and then you get to figure out some probability. All right, so or again, the probability of say rolling a 5 or a 6. So two different outcomes here. Okay, again, we could figure out that probability there, which we will in just a second. All right. Now, the notation associated with probability for events here can be labeled in the book here. They typically label it letter E or letter A. Okay, so letter E is pretty much the generic way to kind of express an event, or letter A. You can literally assign it any letter you want, but those are the 2 most common that they use a majority of the time. All right. So let's talk about how a probability works, at least in terms of a simple one. So, let's see here. All right. Actually, let me do that first, and then I'll go to do that. All right. Okay. So let me do number 3 and number 4, and then we'll talk about that part there. All right. So let's look at number 3. Number 3 says, "What is an unusual event?" Now, this question here, number 3, is something that will pop up a little bit later on in the textbook, okay? This is actually very important because certain questions in the textbook here will talk about if something is an unusual event, okay? If it is an unusual event. So let's look at this question here. It says, what is an unusual event? This happens when the probability is less than 0.05 or 5%. This is a threshold here that is used quite often in statistics if we want to talk about if a particular situation is unique or unusual, given the parameters that you had here in your probability experiment from the very get-go. So again, we do have a metric here for something that is unusual, something that occurs less than 5% of the time. Amazing Poet, thank you so much for the follow. Okay. Now the next thing here, and then we'll go ahead and do some examples here. The next thing we'll talk about here is what's the notation for a probability model. So what we're going to be doing here a majority of the time is we're going to be talking about this notation here, which is the letter P. Letter P here represents probability, and in parentheses we have the subsequent event, whether that be A being the event, or E, you could call it E for E being the event. Doesn't really matter. Whatever you want it to be, it is what it is. More importantly is how we figure out these probabilities. Let's take a look, and then we'll look at those properties there that we see below. All right. Let's take a good look here at some situations. You guys can feel free to answer me here. All right. What's the probability? Let's start off with, let's say we had a 6-sided die. All right, so let's say we start off with a 6-sided die. Let's go with that first. So let's go with the 6-sided die, and I roll a, let's say I roll a 3. All right, can anybody tell me here, what's the probability that I roll a 3? I swear I put that over there, right? I didn't. Maybe it's in the other room. Oh, anyway. That's fine, Fritz. I just need you to answer this question first, and I can do that. Okay. So we have 1 out of 6, right? So the probability of rolling a 3 is 1 out of 6, right? So let's talk about that here. Let's break it down for just a moment. 1 here is the number of possibilities a 3 occurs on the die. So again, out of the total number of possibilities. So by and large, it's not too hard to figure out. All right, you get 1 out of 6 here as part of your answers. So that's how much, you roll a 3. That's perfectly fine. Let me go back here for just a second for you, Fritz. Go ahead and take a quick picture here. Okay, so that isn't too hard to figure out. It's fairly simple and straightforward. All right. Let me go over another one here. All right, let's do another one here. Did you get the picture there, Fritz? I hope so. Cool. All right. So let's do the probability there of, let's say I roll a 4 or 5. Probably that I roll a 4 or a 5. What's that probability, guys? Can anybody tell me? 2 out of 6? You guys help me out. Is it 2 out of 6? Is that true? Is Angie's answer correct? All right. All right. So 2 out of 6 is spot on. I completely agree. All right. So there are 2 numbers here for 4 and 5 out of 6 possibilities. Seems fair. Seems fair. Okay. Yeah, we'll skip that there. All right. Now, I'm going to show you a couple of more here. And I want you guys to answer this for me. And then we'll get, like I said, we'll get to the next set of questions here. But these next couple examples are rather important. So let's do the probability. Let's say I roll a 4. Say I roll a 4 and a 6. Okay. What's the probability that I roll a 4 and a 6? Hmm. 1 out of 6? Hmm. 1 out of 12? All right. Looks like I'll have to do a small poll here. All right. Do it. I can't spell today. It's pretty bad. There we go. Better. 1 out of 6, 1 out of 12. All right, I'll have you guys do me a poll here. All right, so I'm gonna put that up for 2 minutes. I'm gonna be right back. I'm gonna grab something here. You guys do. Alrighty. Let's see here. All right. I'll show you what I got here. Okay, and then I'll put down the answer here. I love little things like this, though. Super fun. Okay, so I'm going to switch to the big board here for just a moment. Switch to away from the big board, I should say. So, next to me here is my handy dandy D&D dice bag. All right, so I got a ton of dice in here, like a lot. All right, so I'm gonna take out one of my D6s because it's, you know, I gotta do the nerdy thing. Get my D6 out. All right, which D6 do I get to be super? There it is. That's the die I want. All right. Let me be a super nerd for just a moment. All right, let's reason out. Okay, so I had people say 1 out of 12. Okay, so 1 out of 12, and then 2 people said, all right, so I had majority of people say, all right, let's talk about what the answer is to this question right here. Back to the big board here. Actually, no, I take it back. Let's go back to this. Shows how much I know. All right, so everybody would agree. This is our 6-sided die right here. I roll it. All right, I roll it, and I get either a 4 or I get a 6. Okay? Well, I'll get a 4 and a 6, I should say. Tell me, how can I get a 4 and a 6? Is that even possible? If I roll the die, can I get a 4 and a 6 at the same time? Is that possible? Let's answer that question. You guys tell me. Can I get a 4 and a 6 at the same time? It's not possible, is it? I have the die. I roll it. It's flat on the ground. But there's no way I can get a 4 and a 6 at the same time, right? So, let's follow this reasoning here. What's my actual probability for rolling a 4 and a 6? Go back to our question here. Ah, there we go. Yes. That is correct. The answer is 0. Yes, that is absolutely right. In fact, there is no chance that we could get a 4 and a 6 rolling it at the same time. I see. This is the part of the probability process that I want to expose you to right away. And this is going to be the most important part of the process here, at least what we'll focus on here today is, ladies and gentlemen, wording is definitely a thing, okay? So again, I'm going to put this as a huge warning flag, all right? Wording is important. We're gonna focus on this quite a bit because other sections and chapters do have trickier wording. All right, so wording is important. All right, any questions about that so far? No, that was a tricky one. That was a tricky one. Man, I know. I fooled all of you. Look at that. I fooled all of you. I'm so evil. All right. I'm impressed. Impressed. I'm so confident in my answer to. I know. But in math, you gotta be like super careful about, especially about the wording. You gotta be super careful about that. Let's show off another one here. How about this one here? Let's show off another one. Yeah, let's do that. All right, how about the probability of rolling at least 2? What's the probability of at least 2? Angie says 4 out of 6. Any other answers? Angie changed to 5 out of 6. Okay, I see 4 out of 6. I see 5 out of 6. Now I agree. One of those two answers is definitely correct. Let's see where everybody falls underneath here. Remember, read this carefully, ladies and gentlemen. Read this carefully. At least 2. At least 2. Okay, so the numbers here of at least 2 is going to be 2, 3, 4, 5, and 6. So in reality, that indeed is true as 5 out of 6. Yes. All right. Got to be careful about that. All right. Again, these are the things I want you to just keep aware about. This is all this wording. It comes up in various problems, so I'm just gonna get you prepared for it now rather than later. That way, you know you've seen it before and be like, oh yeah, I know where this is coming from now. All right, let's try it. Let's try another one here. Let's try another one, okay? How about less than 2? Less than 2. Mike says 1 out of 6. 1 out of 6. Okay. All right, good beans. Yes. I like this. This is good. All right. Then we have less than 2 here. All right. Not so bad. Not so bad, right? You see they got a little bit of wording there. You will see more of this type of wording here in this chapter for sure. But again, I'm just getting you prepared here, getting you a little warmed up. You guys are starting to see through the veil of the wording here. All right. All right. We're in good shape. Okay. Okay. All right. Any questions about that so far? Hopefully that's not too bad. All right. That's like that classic order of operations question. So, if you've seen that before, actually, what is that? Actually, you guys may have seen this before. This is one that I actually like to ask quite often. 6 divided by 2 times 3. You guys seen that before? You guys know the answer to that? It kind of works in the same vein as what we just did for probability. You guys done this before. 6 divided by 2 times 3. You guys know what that is? Which answer do you think this is? There's only like 2 possible answers people come up with, so. Let's do it. Let's do another poll. I love this. This is good. Let's do another poll. There's only 2 answers we're gonna ever have. Okay, quick poll. We're either gonna get 1 or 9. That's what people think. 1 or 9. Probably seen this on like what is this, like a Facebook thing or whatever. It's pretty common. Why don't you could do this math equation or blah 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 blah, right? Let's see what we get here. Get a little bit of fun with probability. That's what I love about this section. Super fun with probability time. Alright, either 6 divided by 2 times 3, 1 or 9. One of those two. PEMDAS, y'all. PEMDAS for the win. Ooh, one person put 9. Ooh. Alright. So who's the one person that put 9? It's fine. It's fine if you say something. If you put the one person who put 9, I'll allow it. You can admit it if you put 9. It's fine. Everybody else put 8. Everybody puts. You did. Skinny says, hey, I put 9. Let's say what the final answer is going to be, because one of either you or the collective mob is correct. All right. And the correct answer for this here, ladies and gentlemen, is exactly 9. That's correct. Good. Skinny, you're correct. The answer is 9. That is correct. PEMDAS is correct. Okay, but you see, that is where we have to clear up misconceptions. That is why I do these probabilities in the same vein. PEMDAS is correct, Angie. You are not wrong. However, when we talk about multiply and divide, so we have P for parentheses, E for exponents, that's perfectly fine. The next thing that people often get wrong is that multiply and divide are the same exact rank. They are not. It doesn't go, you do multiplication before division. Just because it's written before just because multiply is written before divide doesn't mean you do multiplication before division. Basically, here's what I'm saying. What I'm saying is if I replace those with division and multiplication, I would have, say, 6 plus 2 minus 3. Well, you would say, hey, or again, I have 6 minus 2 plus 3. In both of these cases, you'd take it the same way, right? You would go from left to right. Everybody was taught that way. Go from left to right. Add, subtract, left to right. You say, okay, this case is 7, right? You go 6 minus 2, which is 4, plus 3, which is 7. You do 6 plus 2, which is 8, minus 3, which is 5, right? You go left to right. So my contention is, well, why don't I do the same thing with multiply and divide? Well, I can. There's no parentheses here, so I'm not forced to do it in a certain order. So I do 6 divided by 2, which is 3. 3 times 3, which is 9. I see. So whoever taught you multiply comes before divide, they're wrong. Okay? It always is the same rank. That's number 1. Looks like you got more than what you bargained for today, ladies and gentlemen. Mmm. This is where we start breaking those bad habits. Them bad habits. We start looking at things with a slightly different perspective. Hey, welcome to probability. Just a smidge. Just a smidge. Not asking for a ton, I promise you. But if it opens up your eyes, great. That's exactly what I'm looking for. All right. Now, we do need to move forward here. So let's talk about what we just did here. All right. All right. Let's take a good look here in this case, and I'll showcase what happens here. All right. So what are the properties of probabilities? All right, so let's talk about that. Now, probability here, as we can see here on the screen, probability always has to be between 0 and 1, okay? So 0 for 0% and 1 for 100%, okay? So always between 0 and 1. You should never get a probability that is negative, and you should never get a probability that is above 1, okay? If you do, then you know you went wrong somewhere. All right? Now, the next thing it says, if the sample space S is equal to A1 to AN, which is basically all the outcomes in the sample space, so like 1 through 6 or whatever, then the sum of all the outcomes in the sample space must equal 1. Meaning to say, if the probability of rolling a 1 plus the probability of rolling a 2 plus the probability of rolling a 6, if you add them all together, they should equal 1 or 100% at the end of the day. Okay? And you can generalize that to as many outcomes as can happen in the sample space. Note, again, if solving, express it as a fraction if possible, and do the division to reduce confusion. This is true. Okay, so as a fraction, if you're solving for it, express it as a fraction if you can. If you can. Some cases you may not be able to express it as a fraction. Like rolling die is really easy because it's 1 out of 6 or something like that. And do the division to reduce confusion if you have like really messy numbers. So if you have 13 over 17 and it's just an ugly number, well then that's perfectly fine. One of the things that we talked about before is how many decimal places that we're going to be using. Again, we're going to either using a fraction or going to 4 decimal places here, as we did before. Okay, so 4 decimal places here is still going to be our MO here for, again, always going to be our MO for this class, and this chapter here will be no different. All right. Now, let's look at number 6. How do we compute probabilities of equally likely outcomes? So if an experiment has n equally likely outcomes, and if the number of ways that an event A can occur is m, then the probability of A, P of A, is equal to P of A, which is equal to the number of ways A can occur, which is equal to m, over the total number of possible outcomes, which is n. All right? So as we mentioned here earlier, warning, watch out for the wording of the event in question. All right, so we just talked about that very specifically, and now I just formalized it here, at least something that we did certainly see. Okay, so again, as we pointed out here, rolling a 5 on a 6-sided die, how many ways can that occur on rolling a 5? Well, there's only one way that occurs on rolling on a 6-sided die, okay, and out of how many possible outcomes can there be rolling on a 6-sided die? 6, hence where we get the 1 out of 6 definition for our probability. All right. Not terrible, but there you go. Easy peasy. Easy the peasy. All right. Any questions so far? Any questions? Let's do some other probability problems. Okay, I think others. That's not what I wanted to say. That was the wrong thing. Okay, so I'm gonna actually. I'm not sure why I didn't open this earlier, because I'm not smart. That's okay. Being not smart is one of my strong points, so not a problem. Alright, so I'm just going to take a look at the textbook here. And then we're going to do some other examples here together. Excuse me? Excuse me, Pearson. That's not how life works. Okay. Yeah, let me get it to the page here. Oh my gosh, so many pages. Alrighty. Let's take a good look here at this page. Alright. You can see here on the thing. Alright. We'll look at some roulette. Alright, some roulette here. So roulette. In a game of roulette, a wheel consists of 38 slots, numbered 0, 00, and 1 to 36. Alright, to play the game, a metal ball is spun around a wheel and is allowed to fall in one of the numbered slots. Pretty reasonable. Alright, determining the sample space isn't hard, but let's go ahead and do letter B here. Determine the probability that a metal ball falls into the slot marked 8. So determine if it falls into the number 8. So can anybody tell me here, what is the probability that that you get an 8? So I'm gonna go screen. Actually. So we have, again, 0. We got 0. We have a 00. And then we have 1 to 36. Alright, and what's the probability that it lands on an 8? Okay, that's the question we have here for roulette. Anybody tell me here, what's our probability here in this case? Probability that the ball lands on an 8. 8 out of 36? 1 out of 36. Oh. 1 out of 38. Okay. So, yes, that answer is correct. We have 1 8 on the wheel out of 38 possibilities, because 0 and 00 also count as 2 other slots on the actual roulette wheel. Alright. That is true. Well, yeah, gotta be careful about that. Don't forget 0 and 00 also count, because they are part of the sample space. As long as the ball has a possibility of falling in one of those, that's fine. Still counts. Now, the third one here talks about if the ball lands in an odd number. So what happens if the ball lands in an odd number? What happens here? What's the probability that it lands in an odd number? Again, how many possibilities are on the wheel? Let's just go with that first. $38. Okay, now that's correct, Angie. So we can at least get rid of half of that. All right, so 38. That's one half of the problem done. All right, very nice job, Julie. Okay, now, how many possibilities how many things on the wheel are odd? 0 and 00 are not considered odd. No. But that's a very valid question. Very valid question. So if 0 and 00 are not considered odd, then what is our answer going to be? Oh, that's close. Anna and Fritz, very close. All right. So, okay, I do see the correct answer here. So the answer here is correct. This is correct. Is going to be 18 out of 38. So not 19 here, Chioma. That's not one half. The reason is because 0 and 00 both are not considered to be odd. So because both are not considered to be odd, there are only 18 numbers, the ones between 18 odd numbers, the ones between 1 and 36, that count as odd. So that's why it will be 18 out of 38 and not 19 out of 38. So 18 out of 38 would be the correct answer here for the probability of any odd number there. Yeah, so you just got to be careful about the circumstances behind what it's asking you here. So just be very careful. Like I said, the wording not only is important, but it's also, again, what is considered, again, in this case here, the consideration of odd here is exactly just like 135, but not 0 and 00. By the way, I'm just going to point this out here. Never play roulette in a casino. All right? Just don't. We'll actually look later on here in this chapter about how bad roulette really is. If you're talking about trying to make money off roulette, it's pretty bad. So you will lose a lot of money in roulette. So not worth your time, folks. Okay. Okay, next, let's do the next question here. The only game you should ever play in a casino, if you like slots, I guess that's one thing, but is like Texas Hold'em, because the house doesn't control Texas Hold'em as much as other games. So, all right, poker's fine because you're playing against other people, not against the house. All right, so let's take a look here at number 35. Let's look at 35. Blackjack is okay, but the house still has an advantage. And you're still playing against the house in blackjack. I mean, you could ask, like, if you go to a casino, you can ask a pit boss, you know, the guy that kind of looks around the dealers, is kind of in charge of the dealers on the floor. You can ask the pit boss, and you can ask him, hey, can you give me a strategy card for blackjack? And they have these available, and he'll give you one. He'll give you, say, what should you do on 15, and, you know, if the dealer's showing this and that. And they'll actually have a little, you know, they'll have a little side chart here of these blackjack cutout cards. So they'll tell you what to do to either to hit or stay. And the only reason why they have these available is because at the end of the day, they know they're still going to make money irrespective of what your choices are going to be. So if you know that if you already are in favor of making money, then I can give you all the answers, and guess what? I'm still going to make money because that's how the probability is going to work out in my favor. So blackjack, albeit you can make money, certainly true, okay? Again, you could do the whole counting cards, do all that stuff, but still. Moral of the lesson, don't gamble. Or at least if you are going to gamble, at least gamble with more knowledge, or at least where you actually have can gain an advantage through knowledge. Like, even like okay, good example is like sports betting. The best sports bettors in the world only win, on average, approximately 55% of the time is considered elite gambling. 55%. Okay? So, you're an elite sports gambler if you win 55% of the time. Think about that. Okay? And that's very few people who can even remotely come close to that. So, you can consider that way. It's pretty tough to get, you know, above that 50% threshold. It's not easy. Or you could take the example of a baseball player. A good baseball player in the major leagues only gets a hit 3 out of 10 times. So 30% of the time is considered really good in Major League Baseball. An average player gets a hit 25% of the time. I mean, think about it that way. If you want to think about it that way, that's really, if you put it into perspective, you're like, wow. Okay. All right. Let's look at 35 here. 35 says, in a national survey conducted by the CDC, yeah, 250 is pretty good in today's major leagues. 200 is still bad, okay? 200 is still like the level you should never hit, right? Hitting 20% of the time is pretty bad. So, but even 250 is still considered pretty good in today's day and age, considering everybody strikes out like a ton. In a national survey conducted by the CDC to determine college students' health risk behaviors, college students were asked, how often do you wear a seatbelt when riding in a car driven by someone else? So the frequencies appear in the tables. So here are the frequencies. All right, so never, rarely, sometimes, most of the time, or always. People who say never are not smart. All right, so wear a seatbelt, folks. That's always a good thing. Okay, so first things first here. Let's go ahead and just use this little table here. I want to know the probability of people who wear a seatbelt most of the time. Okay, so let's do that right now. Put this on the side here. Right here. So just a really quick one here for this one. Anybody tell me here, what would be the probability of most of the time? What do you guys think here for 35? Probability of most of the time. What would that be? How many people, okay, how many people are most of the time? Let's at least get half of it right. Okay, so let's get half the problem correct. How many people are most of the time? So according to the chart here, how many people are most of the time? All right, 1257. That's correct. All right, very good, very good. So that's half the problem, guys. Half the problem is just recognizing how many possible ways we can get most of the time. All right. Now, how many people were surveyed here? How many total people were surveyed? So if we add this up here together, then we'll tend to take, again, down here will be 125 plus 324, and that is correct. Plus 324 plus 552 plus 1257, and then plus the 2518. I know this looks pretty jank. All right, so here we get to 1257, and all of you correct here, 100%. That'll be 4776. Now, admittingly, as a fraction, looks pretty ugly. All right, so in this case here, these numbers aren't so nice. So let's put this in decimal format here. Can you guys give this to me as a decimal format, and we'll go to 4 decimal places as our usual MO. So what's our decimal thing here? Give me the decimal here. 1257 divided by 4776. 0.2632, okay? All right. Okay, good. That'll be our final answer for this problem. Excellent. That's okay. That's okay, Skitty. That's not a problem. All is well. All right. Questions about that? Any questions? Hopefully that's not too hard. At least I hope so. Oh. Good. Oop. All right. So far, so bueno. Oh. Alrighty. Let's take a good look here at the next one here. Good, good. All right. Alrighty. Let's take a good look here at number 7. Now, number 7 is certainly something that we do talk about quite often when it comes to certain things. Now, what we use typically, if we're talking about saying kind of do future projections or just projections of probabilities in general, is we have what's called the empirical method. Okay, so the empirical method, what is that? The empirical method usually involves a large amount of trials of an experiment. So the best example is this. All right, now if we flip a coin, now let's think of it in a realistic term here. If we flip a coin, no matter what, the probability of getting heads or tails is still going to be 1/2. So 50% of the time you should get a head, 50% of the time you should get a tail. Seems pretty reasonable. The only issue is that if I tried, let's say I flipped the coin 10 times. If I flip the coin 10 times, okay, it could be possible that I flip the coin 10 times, 3 of them could be tails and 7 of them could be heads, okay? But that doesn't actually reflect the actual 50-50 composition of actually flipping a coin. So what you have to do here is, again, flip the coin. Maybe not 10 times doesn't reflect that true 50-50 of actually flipping a coin. You flip the coin, say, instead of 10 times, flip it 10,000 times, okay? And then if you flip it 10,000 times and you record if you get heads or tails on each one, you'll see that it's going to be pretty close, odds wise, it's going to be pretty close to that 50-50 composition, that 50-50 split that it's supposed to be at the end of the day. So the bigger the sample size that you're going to have, the much more reflective the actual probability will be, because now you're taking many trials into account as opposed to a very limited set. So this kind of goes back to what we talked about quite a while ago, saying, hey, having a small sample size is not enough to really make a determination. We need a lot of these trials sometimes in order to make the actual proper determination to see exactly what that probability, say, distribution is going to be based on those outcomes. So a coin is probably the easiest one, since you expect and have a full expectation of a true kind of 50-50 kind of outcome between when you flip the coin. All right. So you want to make it more accurate at the end of the day. So you need a sufficiently large enough sample size to make a proper conclusion. And that's what we try to strive to do in statistics is all the time, is basically get a big enough sample size to basically then go ahead and extrapolate that to a population. Said, okay, this is a big enough sample size to make a conclusion that, yeah, the population will probably show this way, okay, these results at the end of the day. That's something that's fairly important to do. So we'll talk about the empirical method here, and yeah, that's what we try and do for that. Now, all right, not too bad about that. Okay, all right, let's go ahead and take a look here at yeah, I guess how much time do I have? 15 minutes. Okay, I got 15 minutes. Eh, what week am I? Where are and kind of cruising through this really fast. So I don't know. What do you guys think? I'm gonna leave it up to you. You guys want to stop here and just start from section 5.2 next time? What do you guys want to do? I'll leave it up to you. I leave it in your hands. Stop or go. Stop. Yeah, stop. Okay. We're actually the reason why I say it, because we're pretty ahead of the curve. So we're in week 4, and then we're already starting like the 4th chapter. So we're like really ahead of the curve in terms of material. So we can yes, okay. Nav's like, stop the things. all of the things. Be like, okay, that's fair, man. That's fair. Goodness, goodness. All right. Okay, that's fair. So this is where we're stopped for today. We're gonna come back here on Thursday, and we will start on question 8. Okay, so question 8 is where we are going to your Angie, I broke your brain from PEMDAS. Fine. Angie, you can Angie plug it in a calculator and then plug it in your graphing calculator and you'll see that I'm right. All right? All right? I'm just going to point it out there. All right? That's so mean. Plug it in the calculator, it'll tell you I'm right. I'm just that amazing. Bam. Oh my goodness. No, I don't need to know that I've been lied to. Oh no. Yes, unfortunately, unfortunately, these are bad habits that are taught sometimes by people who don't know the actual behind that bad face. Um, yeah, been kind of lied to. Yeah, I ain't gonna lie. But not by me, I promise you that. Not by me. Promise you that. All right. Okay. Well, I'm going to stop here for today, ladies and gentlemen. You guys have asked me to stop, so that's where I'm going to stop. We're going to start with question 8 here on Thursday. We're at a really nice pace here, guys. So we just got through section 5.1. So if you're working through the homework here, section 5.1, if you've done the tests and stuff. So again, first things first here, make sure you're doing the homework for chapters 1 through 3, okay, and doing the test for chapter 1 through 3. So again, that's the first priority you should have if you're keeping with the homework and the test stuff. Once you do finish that, though, then start at section 5.1. That is going to be the next one up on the table. Okay, so I could go through here slow, so that way, again, you'll have a reasonable idea to catch up with assignments that are happening right now. So, uh, yeah, that should be pretty simple stuff. All right, very good job today, everybody. Excellent work here today. All right, all right. Does anybody have any questions before we head out for today? Any questions? Okay. All right. Make sure everybody's cool. Okay, gotta remember that. All right, very good. All right, nice job, everybody. All right, thank you so very much for coming on the stream. I love you all. We will come back here on Thursday, start question 8. All right. Hopefully, I haven't totally broken you by today, but lot to look forward to. Thank you so much, Chioma. Thank you. All right, thank you for coming out. Okay, you guys should thank yourselves for wanting to be better. All right, that's the more important part here. You guys come out every time. You guys want to be better. You guys are You guys are improving every single day. All right. Let's continue this. Let's continue the positivity train moving forward. Okay. All right. All right, everybody. We'll see you later. All right. Have yourself a wonderful evening, and we'll see you in a couple days. Test is due the 23rd. Correct, Juan. Yes, that is correct. Yes, that is right. The 23rd. You are absolutely spot on. You know what? Just in relation to that one, I may post an announcement in D2L and send you an email just as a reminder. So, I may go ahead and do that actually. So, I may do that tonight. So, thanks for letting me. Yeah, I probably should do that. So, all right. In any case, thank you, everybody. All right. And as always, everybody, stay safe, stay healthy, but most importantly, stay sane. All right. Have a great day. Have a great evening. All right. We'll see you next time, everybody. Take care of yourselves. Have a great one. Bye. Bye, everybody. Take care.